Okay, algebra students, we'll see if this will give it a go. We are continuing working with graphing linear inequalities. Today we're going to have systems of inequalities. So I'm going to share my screen and start the presentation. So we are starting out with some vocabulary. And this goes in your journal on page 164. And it is the definition of a system of linear inequalities. Very similar to a system of linear equations, only this is inequalities. So we have two or more inequalities together, and the solution is any ordered pair that makes each inequality in the system true, so it has to make them true. So if you look at where these colors are overlapping, that's where the solutions are to this system. So we're going to look at an example. This is extra practice, page 165. And it asks you to tell whether the ordered pair is a solution of the system. So it has to work in both inequalities. I'm going to replace the x values with -1 and the y values with 1 and see if it's true. So this is x and this is y. So in the first case I have, is 1 less than 3? That's what I have to decide. And I think we can all pretty much agree that that's true. So I'd say yes there. Here I replace y with 1 and x with -1. And I have to see if that is true. So let's see, is 1 greater than -1 minus 4 is -5? Is that true? Certainly. So the question is the ordered pair a solution to the system? Since we got a yes answer for both of these, our answer is yes. If you get a yes and a no, or a no and a no, then it is not true for the system. All right, let's look at some graphing. It says when graphing a system of linear inequalities, it says the solution, let me see if I can move this out of the way. I don't know if that's in your way. The solutions to the system are the points in the region where the shaded regions overlap. So this first one, I have y is less than 3. Oop, forgot to grab my pen there. Y is less than 3, that's a horizontal line. Notice it's not equal to, so I'm going to make a dotted horizontal line at 3 on the y-axis. My solutions are all the points that are less than 3, so anything down here. I'll just color those with those lines. All right, I'm going to switch colors for the other graph. This time I have x is less than 2. That's a vertical line, a dotted vertical line, right? Because it doesn't say equals. And solutions to that, any number less than 2 would be on this side of that vertical line. And so our solution is where these two regions overlap. So it's bounded by the 3 up here and the 2 on the right. It doesn't include those lines, but any point in here should work in the system. So again, you can always try your test point. In this case, again, I could pick 0, 0. We can see that 0, 0 is clearly in this region where both colors are. So is 0 less than 3? Does it work there? Yes. And for the x coordinate, is 0 less than 2? Yes. All right, so our 0, 0 is in fact a solution to the system. All right, let's look at our next sign. This is extra practice. Number 7. So solve the system of inequalities by graphing. So this time I have to graph my two lines. In this first line, my y-intercept is -2. My slope is up 1 over 1. I'm going to have a solid line, and I'm going to, since it's greater than, I'm going to shade above the line. Remember, greater shade above, less than shade below. Okay, so I'm going to shade above the line. Y-intercept -2. My slope is up 1 over 1, up 1 over 1. So I'm going to do several points here so I can oh, that should have been up here. I want to make sure I'm pretty accurate here. It's kind of hard to draw on this. All right, so this line is solid. Oh, beautiful. Oh my. Oh. And I'm shading above that line, so up here. All right. This line, I'll switch colors. This time I have my y-intercept is +2. my slope is a negative 1/1. This time it's a dotted line. And because it is less than, I'm going to shade below the line. So y-intercept positive 2, slope is negative 1/1. See if I can do a better job of drawing a line this time. I have a dotted line going through here. I'm shading below the dotted line, which would be over here. So again, my solution region, I'm gonna switch colors again. I wonder if there's a way to do more than, let's do purple here. My solution region is all of this overlap. So any point in this region where the two lines overlap. Be nice if there was like a way I could color more than just skinny little lines. All right, so you can kind of see your solutions there. Again, you can pick a point. We could try 0, 0. Is 0 greater than 0 minus 2? Yes. Is 0 less than negative 0 plus 2? Yes. So 0, 0 would work, and it's in our shaded region. So again, our solution is that kind of purpley color I have there. So it's bounded on the top by this line and on the bottom by this line, and it's any point in that shaded region. And you'll be using colored pencils. They won't be quite so messy on this. All right, so it says your assignment is 5.7. It is not this. You guys have a worksheet. Oop, let's go back to that last slide. Let's go back to here, see if I can get to that end slide. Nope. Really get it going back to that. Let's try it again. It is written on your agenda what it really is. So it's not this, okay? It is a worksheet, and the link to the worksheet is on the agenda calendar. So again, good luck. Email me if you have any questions. I think it's pretty straightforward. There's also pages in your book you can look at, or in your journal that you can check out, and that should be helpful too. So good luck.